MS Ramaya University of Applied Sciences.
Let us discuss the determination of the thickness of a given paper by observing interference at an air wedge. This experiment is based on the phenomena of interference. Interference is a phenomena of superposition of two or more waves when they meet at the same point. The resulting amplitude will depend on the amplitudes of the individual waves at that point. Two waves can interfere constructively or destructively depending upon the phase or path difference between them, as shown in figure. Air wedge is a thin wedge-shaped air film formed between two glass plates when one of their common ends are in contact and a thin object is inserted between the glass plates at the other end, as shown in figure. Interference fringes are produced due to the superposition of light waves reflected from the lower surface of the upper glass plate and the upper surface of the lower glass plate. When monochromatic light source is used, interference fringes in the form of alternate dark and bright bands are obtained. Bright fringes correspond to regions of constructive interference and dark fringes correspond to regions of destructive interference. Thickness of the air wedge increases along the length of the air wedge. Path difference between the light waves reflected from the two surfaces is equal to 2 mu t, where T is the thickness of the air wedge and mu is the refractive index of the medium. Constructive interference occurs when the path difference is equal to integral multiples of wavelength, and destructive interference occurs when the path difference is equal to half integral multiples of wavelength. By measuring the fringe width of the interference fringes and the length of the air wedge, the thickness of the given paper can be calculated using the formula as shown.
Hello students, in this experiment we are going to measure the thickness of a thin paper using air wedge setup. The apparatus required are two glass plates, a thin paper, travelling microscope, a reflector, sodium vapor lamp, reading lens and a light source. In this experiment we are going to measure the thickness of the paper which is fixed at one end of the glass plate. Now when the other glass plate is kept over the below glass plate, a thin air film in the form of a wedge is formed in between the two glass plate and this is called an air wedge. Now let us start the experiment. First take the reflector and keep the reflector parallel to the light source. Next take your air wedge setup and keep it below the reflector. This reflector is used so that the light falls normally on the air wedge setup. Next take your travelling microscope and keep it over the entire setup. The glass plate, the air wedge setup, all should be in a single line. Looking through the eyepiece, rotate the reflector till the field of view is bright. If the field of view is bright, it indicates that the glass plate is at 45 degree. Now looking through the microscope, focus the microscope till you get bright and dark linear fringes. Now looking through the microscope, rotate the drum so that the cross wire is coinciding with one of the dark ring, that is your 0th dark ring. Now note down the main scale division and the vernier scale division. This gives the readings for the 0th dark fringe. Next look through the microscope and rotate the drum so that the cross wire is coinciding with the second dark fringe. Note down the corresponding main scale reading and the vernier scale division. Similarly, looking through the microscope, rotate the drum so that the crosswire comes to coincide with the 3rd, 4th, 6th, 8th and 10th dark ring. Next, take out the air wedge setup and measure the length of the air wedge, that is the length from the outer point of the glass plate to the inner point of the paper. Now, all the measurements have been completed. From the obtained values, the thickness of the paper can be calculated using the relevant formulas.
At MSR UAS, we spark your imagination unlike any other.